In the third topic of the lesson, we will talk about magnetism. A magnet is a material, or object, that produces a magnetic field. This is the very important definition for magnet. The magnetic field is the area where the force of magnetism acts on another magnet, or magnetic object. Magnetic field is with direction, it is generated from North Pole toward the South Pole. When a magnet is placed in the magnetic field, it will be attracted toward the field. North pole of the magnetic, toward the south pole of the field. South pole of the magnetic, toward the north pole of the field. This magnetic field produces an attraction force that pulls on magnetic materials like nickel, iron, and cobalt. A magnet can exist as a magnetic stone, and it can be made from magnetic material like iron, nickel, steel, and cobalt. Magnetic stone is the stone that naturally occurring magnets. The following are the characteristics of a magnet. Magnet attracts magnetic object. Magnet has north and south poles. Magnet shows the north-south direction when hung freely with a string. The north pole of magnet is named because it will pointed to north when hung freely. And this is same to south pole of magnet. Magnet repels the magnet in the same pole and attract the magnet in the opposite pole. The pattern of the magnetic field can be observed by sprinkling iron filings on a sheet of paper and bringing a magnet up close to the underside of the paper. We can see that the iron filings line up along the lines of force of the magnetic field. The following is the characteristic of the magnetic field. The direction of the magnetic field lines is from the North Pole to the South Pole. The area has the closer magnetic field lines, has a stronger magnetic field. The magnetic field lines will never cut across each other. When two same poles of magnet bring close to each other, their magnetic field push each other away. This new topic is electromagnet. An electromagnet is a conductor with temporary magnetic effect. When the current flow through the conductor. The key word here is temporary magnetic effect and current flow. In an electromagnet, when the current flows through a conductor, a magnetic field is formed around the conductor. When the current is stopped, the magnetic field disappears. The pattern and orientation of the magnetic field is depend on the shape of the conductor that carries the current flow and the direction of current flow. The following are the conductors in different shape that used to make the electromagnet. The first is straight conductor. Straight conductor can be a straight cable. The second is coiled wire. Coiled wire can be made from straight wire, at which the straight wire is shaped into coiled shape. When the straight wire is shaped into multiple coiled, a solenoid is formed. The pattern and orientation of the magnetic field of the following conductors will be detailed in the coming section of lesson. We first talk about the electromagnet formed by straight conductor. A straight conductor produces a circular magnetic field pattern. When the current flow through straight conductor, you need to imagine that the circular magnetic field pattern occurs along the straight conductor. The direction of magnetic field can be determined by using the right hand rule. Take your right hand and wrap your fingers with your thumb, pointing it to the direction that the current is flowing. Your four fingers now represent the direction of the lines of magnetic field. The lines of the magnetic field are closer when nearer to the wire. This show the magnetic field is stronger when closer to the wire. Now, we talk about the coiled wire electromagnet. A current-carrying coiled wire produces a closer magnetic field lines at the center of the coil. This shows that the magnetic field, is strongest at the center. The direction of the magnetic field can be determined by using the right-hand rule. Let your thumb pointing to the direction that the current is flowing, and your four fingers represent the direction of the lines of magnetic field. About the solenoid. Solenoid is formed when coil wound into a tightly packed helix. Solenoid able to generate a nearly uniform magnetic field, similar to that of a bar magnet. The pole of the solenoid can be determined by looking at the current at the ends of the solenoid. The end, where the current that flows in a clockwise direction, is the south pole. The end, where the current that flows in an anti-clockwise direction, is the north pole. This topic is factors that influence the strength of the electromagnet. There are two factors that influence the strength of the electromagnet. The first factor is the magnitude of the current that flows across the conductor. The strength of the electromagnet increase when the magnitude of current increase. The second factor is the number of coils. The strength of the electromagnet increase when the number of coils increases. This is the last topic of the chapter, application of magnet and electromagnet in our daily life. Compass is an example for the application of magnet. The compass function to use a magnet to assist its pointer needle to show the poles of the earth. The north pole of the magnetic will point to the north direction of the earth, and the south pole of the magnetic will point it to the south direction of the earth. Lifting electromagnet is an example of electromagnet. The electromagnet, attached to a forklift, is used to lift and transfer metal objects, like waste iron, from one place to another place. Electric bell is an example of electromagnet. When the switch K is pressed, the current flow through the circuit, and the iron base E will be magnetized. The iron armature C is attracted to the iron base E, and the mallet A hit the bell B to produce sound. When this happens, it leaves a space at the touch point T, which causes the power supply to be cut off. The iron base E loses its magnetization, and the iron armature C goes back to its original position. This process will be repeated until the switch K is released. This is the full content of topic 3. And we have just completed the learning of chapter 7. Thank you for watching.